FIBRE4YARDS Shipyard 4.0, enhancing the quality of shipbuilding while reducing costs and environmental impact. The FIBRE4YARDS project started its journey with a major challenge ahead, transforming the European ship manufacturing industry by defining a new 4.0 shipyard. Collaborative, digitalized, automated, more efficient, and environmentally friendly. After nearly 3 years of intense research work, the FIBRE4YARDS Consortium is proud to present the 3 pillars on which this new shipyard is based. New technologies for automated ship construction, a digitalized shipyard and its digital twin, and new engineering tools for ship design that take new production technologies into account. FIBRE4YARDS' advanced automated production methods can be adopted by shipyards or used by shipyard suppliers to produce components for assembly in the shipyard. The latter approach minimizes implementation costs and improves process efficiency and quality by allowing suppliers to specialize in specific manufacturing technologies. These new manufacturing technologies have recently been presented to the industry, which is following FIBRE4YARDS developments with great interest. These are:
Out-of-die recurve pultrusion is a unique solution that enables the automatic production of highest performance structural, straight and curved profiles. With this solution, ship yards can directly bonded outward stiffness to the desired area, such as the hull, the deck or the superstructure, eliminating manual lamination and the polyurethane molds, which also means the reduction of operational costs and the final vessel.
At NXL, we developed robotic-based systems for additive manufacturing to build up a rough shape using recycled polymers. For CNC manufacturing, finish the rough shape towards the net shape and to smoothen the surface, and automated tape placement to reinforce the prints with unidirectional tapes, all within a fully automated production environment.
Yacht stamping of thermoplastic composites, also commonly called stamp forming or thermoforming, is a manufacturing process where a continuous fiber thermoplastic composite sheet is heated and then shaped using a rigid mold. This technology allows the production of tailored lightweight structures with excellent strength-to-weight ratios. As shown in FIBRE4YARDS project, it is ideal to produce small to medium-sized parts in an accurate and fast manner, and could represent a major player in the modularity scenario of future shipbuilding.
Adaptive molds are game-changing for building composite ship structures, because now we can think about modular building in a similar way as with metal ships. We use adaptive tooling to manufacture prefabricated panels with the correct geometry, shape, and joint design, and assemble them together into a complete structure using very simple jigs. It means that we don't need those large and expensive tools and the infrastructure necessary in traditional composite shipbuilding, and we can go as large as we want.
All the developed technologies envision shipbuilding as a modular construction process. Therefore, FIBRE4YARDS has defined best practices for the successful assembly of all ship components and structural parts, taking into account material requirements and process specifications. The new 4.0 shipyard defined by FIBRE4YARDS will be digitally connected. A detailed monitoring strategy has been defined for all technologies developed under the project, which will allow real-time identification of key manufacturing parameters. This monitoring will enhance quality control and will be used to develop maintenance plans to improve process efficiency and environmental impact. All data obtained from the process is integrated into a digital twin of the shipyard using Internet of Things protocols, which can be customized for each process and can integrate the information of the shipyard and all its suppliers. This platform has also been presented to the industry and has raised great expectations.
OC4ED, it's a web-based platform for IoT that has the aim to monitorize in real time industrial assets and structures. One of the prides of this project is that it is open source because we wanted to make it available for everyone. If I had to pick on some strengths of the platform, I would say that it has outstanding 3D visualization, built-in a web interface which is portable, and also something that is very unique is the 3D simulations in real time that come from or are integrated from finite element solutions.
FIBRE4YARDS has also developed a new design software that includes specific formulations for analysing vessels manufactured with the newly developed technologies. The software includes specific functions to evaluate, for example, connections or 3D printed materials. This software will make it possible to optimize the ship's structure, reduce its weight, and improve its efficiency. The introduction of all these new technologies in a shipyard must be done together with life cycle analyses of the processes and materials in order to minimize the environmental impact of shipbuilding and the resulting ship. The initial analyses carried out as part of the project have shown that material selection is of paramount importance in reducing environmental impact. FIBRE4YARDS has also produced guidelines to facilitate the use of the different technologies developed and business plans for the resulting shipyard, which will benefit from a collaborative approach to shipbuilding, shorter production times, and reduced maintenance requirements and costs.
In FIBRE4YARDS, we have proved that it's possible to rethink the shipyard. If we digitalize it, if we move from manual construction to automated processes, if we incorporate modular construction, and last but not least, if we incorporate and we use numerical tools that can take all these processes into account, then we'll be able to build ships that are cheaper, that has higher quality, and which environmental impact is reduced through its life cycle.
FIBRE4YARDS is here to help you. Are you ready to cast off?